Okay, so next we have COLIN from the Faculty of Science, Medicine and Health, and the title of his presentation is Of Mice, Pigs and Men, the Facts of Long Life.
I want to live forever, but more realistically, how long can you and I hope to live? My grandfather often quotes Psalm 90:10, the years of our lives will be 70. Sounds impressive, right? But that's only 70 years. And my granddad is already in his 80s. Madame Colmar, pictured here, lived an incredible 122 years, which is the longest human life on record. Madame Colmar was born before penicillin, X-rays, or most of the modern medical advances you and I take for granted. And she smoked for 98 years. You're probably thinking that Madame Colmar was exceptionally lucky to live such an exceptionally long life. You would be right. But in comparison to other mammal species, most humans will live exceptionally long lives. To illustrate this point, I have a graph with mammal longevity on the vertical axis, mammal mass on the horizontal axis. Every black dot represents the long life of a different mammal species that's been studied. And as you can see, as mammal species get larger, they tend to live for longer, so that the little mouse in red lives 3 or 4 years. The larger pig in blue can live up to 30. Humans in green are almost off the scale. We are outliving all the other mammals, which is great news. But the question is why? A major cause of aging in our cells are free radicals. These free radicals are very useful in a small amount, but very, very dangerous when out of control. They are like a fire in our cells. And these free radicals love to burn fat. Not the biggest loser kind of fat, but the fat that forms a membrane around every cell in our body. The fats that are fundamental to our lives. And not all fats are equal. Some fats are very resistant to this free radical damage. Some fats are all too vulnerable, burning up quickly and then spreading the damage by setting out sparks of their own. Mammals that live longer tend to have more of these resistant fats, less of the vulnerable fats. But what about us? What about long-lived humans? To find out, I compared the membranes from mice, which have been extensively studied, pigs, which have a comparable mass to humans but shorter lives, and humans. I looked at the membranes of brain, muscle, and liver. 3 very different tissues with very different function, but one consistent finding. In each tissue, human membranes had more of the resistant fats, less of the vulnerable fats. Human membranes are more resistant to free radical aging and the damage. This was particularly true in skeletal muscle. So, as my research has shown, our human longevity is partly explained by the way our membranes are more resistant to the types of damage that cause aging. Our magical membranes are keeping us younger for longer. So although you and I might not live forever, we still have a far better chance of beating Madame Colmar's record than any mouse or pig could ever dream of. Thank you.
Hello. Are there any clinical applications for your research?
There are certain things you can do to improve these resistant fats. Unsurprisingly, one of them is exercise. But generally speaking, a huge increase, besides the kind of increase that's seen between a human and a pig, is impossible to get through clinical applications. There are some things you can do to get a small increase, but to get an increase again would, I think, be very, very hard to achieve.